We will now discuss the solution of a problem from the section Differential Calculus. The problem is based on the concepts of increasing and decreasing functions. This question has appeared in the Joint Entrance Examination Main held on 25th June 2022 in the first shift. The given question is, let f and g be functions from the set of real numbers into itself, and they are defined by f of x is equal to log of x square plus 1 to the base e minus e power minus x plus 1. G of x is equal to 1 minus 2 times e power 2x by e power x. Then, for which of the following range of alpha the inequality f of g of alpha minus 1 whole square by 3 greater than f of g of alpha minus 5 by 3 holds? We are given four options. Option A, open interval 2 comma 3. Option B, open interval minus 2 to 1 minus 1. Option C, open interval 1 to 2. Option D, open interval minus 1 to plus 1. We are given two functions f and g, which are real valued functions defined on the set of real numbers. And these functions f and g are defined like this. And we have to find the range of alpha for which this inequality holds good from the given four options. We will now discuss the solution of the problem in detail. We have two functions, f and g, which are real valued functions defined on the set of real numbers, defined like this, f of x like this, g of x like this. Now, to talk about the range of alpha for which that given inequality holds will be easier if you know the nature of these functions, that is increasing and decreasing nature of these two functions. If I know, then attacking that inequality and talk about the range of alpha for which that inequality holds good will be easier. Therefore, we discuss the increasing and decreasing nature of these two functions f and g. First, we talk about f of x. We take f of x and take its first derivative. F prime x is equal to the derivative of log of x square plus 1 is 2x by x square plus 1. And the derivative of minus of e power minus x is plus e power minus x. Now the question is it greater than 0 for all x belongs to R? Is it less than 0 for all x belongs to R? That's what we want. So let us say, assume that f prime x is equal to 2x by x square plus 1 plus e power minus x is less than or equal to 0 for all x belongs to R. This means 2x plus 2x by x square plus 1 is less than or equal to e power minus x. That will imply 2x is less than or equal to minus e power minus x into x square plus 1. So first of all, 2x by x square plus 1 is less than or equal to minus of e power minus x. Multiplied throughout by x square plus 1, we will get 2x is less than or equal to minus of e power minus x into x square plus 1 for all x belongs to R. And we need not worry about the inequality because x square plus 1 is always positive for all values of x. So the inequality will not get disturbed. Now in this, put x is equal to 0. If I put x is equal to 0, 2x will be 0 less than or equal to minus e power 0, 1 plus 1 into 1. So that is, we'll get 0 less than or equal to minus 1. So if you put x is equal to 0, we get 0 less than or equal to minus 1, which is a contradiction. See, why minus 1 is strictly less than 0 is the truth, is the fact. But we get this one. This is an absurd thing. Therefore, we get a contradiction. This contradiction tells you that f prime x is less than or equal to 0 for all x belongs to R is not true, is false. Therefore, f prime x is equal to 2x by x square plus 1 plus e power minus x is not less than or equal to 0 for all x belongs to R. This will imply f prime x is greater than 0 for all x belongs to R. So f prime x is greater than 0 for all x belongs to R. So that will imply f of x is an increasing function. So that is the f nature of the function f. It is an increasing function. What about g of x? Second, we have g of x is equal to 1 minus 2 into e power 2x by e power x. That is 1 by e power x is e power minus x minus 2 into e power 2x by e power x will be minus 2 e power x. Now take the derivative. So g prime x is equal to e power minus x derivative is minus e power minus x. And the derivative of 2 e to the power of x is 2 e to the power of x with a minus sign minus. So the minus is common. Minus into e power minus x plus 2 e power x. Now e power minus x is greater than 0 for all values of x. E power x is greater than 0 for all x belongs to R. So this whole thing is greater than 0 for all x belongs to R. But there is a minus sign outside. Therefore, it's less than 0 for all x belongs to R. Therefore, g of x is a decreasing function. So that is the nature of the g. We continue in the next slide. So we have already proved f is an increasing function and g is a decreasing function. And we want to find the range of alpha for which this inequality holds good. So first of all, let's take the inequality. F of g of alpha minus 1 whole square by 3 is greater than f of g of alpha minus 5 by 3. This will imply f of x1 greater than f of x2 implies x1 greater than x2. Why? Because f is an increasing function. Therefore, this will imply g of alpha minus 1 whole square by 3 greater than g of alpha minus 5 by 3. Now again, look at this g. Look at this g. G is a decreasing function. So g of x1 greater than g of x2 will imply x1 less than x2. That is the decreasing nature. So this will imply alpha minus 1 whole square by 3 less than alpha minus 5 by 3 because g is a decreasing function. Now expand alpha minus 1 whole square and take the LCM. We get alpha square minus 2 alpha plus 1 is less than 3 alpha minus 5. Adjust the terms. Then we get alpha square minus 5 alpha plus 6 less than 0. Then we factorize. Alpha minus 2 into alpha minus 3 is less than 0. And we know alpha minus 2 less than alpha minus 3. Alpha minus 2 multiplied by alpha minus 3 less than 0 will imply alpha belongs to the open interval 2 comma 3. This is a very well known result. Yes. So the range of alpha is this one, the open interval 2 to 3, for which this inequality holds good. That's our answer. And let's look at our options. Our answer alpha belongs to the open interval 2 comma 3 appears against option A. Therefore, the answer to this question is option A. That is the detailed discussion of the solution of a problem from differential calculus, which is based on the increasing and decreasing nature of the two given functions. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.